Okay, we're going to try to do some splaining. We're going to try to splane backspace, offset, and rim width. I don't know why we need to splane that, but we're going to do it anyway. So we'll bring our wheel over here. The first thing, this is a 15-inch wheel, and it's advertised at 8.5 inches wide. So that measurement is inside lip to inside lip. That's how wheels are measured, in between the mounting surface where the tire sits up against the rim. So that really measures, give or take a few little lines, 8.5. And then we have the overall width, which you very rarely get, and that's about a 9.5. So what that means is that from where the tire mounts to the very outside lip is about a 1/2 inch on either side. And that may or may not be important, but could be good to know. The next thing that we deal with is backspacing. And confusingly so, there's a big word, that is the distance from the mounting surface in here that mounts up against your hub, brake drum, disc, whatever it is, to the very outside lip of the wheel. So that's backspace. That's the distance from here to here. And when we do this in the backyard style, we just lay our straight edge across there. And again, we have 4 inches of backspace. And we subtract a 1/2 inch from that, and that ends up being 3.5. And when we do the same thing on the outside, measuring to this face, we end up with 5.5 inches, and if we take away the 1/2 inch for the thickness of the rim, we end up with 5 inches. So we're 3.5 here and 5 on the outside, and that's a difference of 1.5 inches. So we take half of that to get back to our center line. That's 3/4 of an inch, and that ends up being about a 20 millimeter negative offset. 3/4 of an inch is 19 millimeters, 20 millimeters, I mean, to get right down to it. So in my backyard math, that means this wheel has about a negative 20 millimeter offset, and that's okay on some vehicles. If you got big openings, big wheel openings, that's cool. Doesn't work for me though. It's easy to see that offset when you see how wide this wheel is, how much of a dish is. Now you could also, as an example, measure from this face out here to the inside edge of where the wheel mounts and come up with that number, and if you subtract those two numbers, the offset should match. So when you're trying to figure out what kind of wheels, are you confused yet? What kind of wheels to put on your car and how wide they should be, you really need to know all of those things. In general terms, I mean, back in the day, they called them reversed wheels, and they called them that for a reason, because they would take the center and cut it out on a steel wheel and turn it around and move it farther back in the rim so the rim stuck out farther, or they would cut the wheel down the middle and widen it, but there was always more wheel to the outside than there was to the inside. But nowadays, with everybody has aluminum wheels of some type on their car, it seems, and the manufacturers all build in some sort of offset, positive or negative, to keep the tires and wheels under the fenders. And to make it even more confusing, they do it in millimeters. So you know, you got to do your homework. There's no two ways about it. You can't just slap a set of these, order them up and slap them on your car and hope they fit. And this conversation really goes back to our Pinto project, in that we have a set of wheels on there that are 15 by 7.5, and I believe when I measured it, they have like a 3.5, 3.3 3/4 offset. And what I really need is a wheel that has not 3 3/4 offset, 3 3/4 backspace. And what I really need there is a wheel with a 4 to 4 1/4 backspace, and that would amount to about a 0 or even a little positive offset, and that would tuck that wheel inside the wheel well. I have room towards the inside, but I don't have room towards the outside, so you know that's why we started looking into this. But it can be confusing, no two ways about it. But you know, we'll just recap there. You have 3 different measurements. You have the width of the wheel where the tire mounts, and that's generally the advertised width. You have the overall width, which is never advertised. And you have back spacing, which is the distance from here to this very outside lip. That's the back spacing. And then you have the offset, which is the distance from this mounting face towards the outside or towards the inside of the center line of the rim mounting surface. So, yeah, we're continuing on wheels and tires on this project, and we made ourselves a crib sheet. Sometimes, you know, you just can't see it in your mind. It's better to put it on paper. So this is what we have now. We have a 7.5 inch wide rim. I also have a set of 8.5 inch wide rims. And what we've done is defined the center line, define the overall width, and then we have the back spacing and the offset. So in this particular case, what's on the car is a 7.5 inch rim. It's 8.5 inches overall, outside to outside, because they measure the rim width inside to inside, so you have to add those 2 lips. And that would make the center line 3 3/4. And then this is what we have for back spacing. And what confuses the issue is that, well, it can, is that you have to subtract a 1/2 inch from that to really get the back spacing the way they measure it. So this particular wheel has a minus 12 millimeter offset, which means that the center of the wheel is towards the inside rather than the outside, and that gives you that sort of deep look. The problem with that is we've got more wheel to the outside than the inside, and our tire, essentially, by the time we put our tire on there and you get the tire shoulders, our overall section width ends up being 10 1/4 inches. So, you know, I'm just trying to look for the measurement here. This wheel is 8.5 inches overall, and so we go to 10 1/4, which is almost 2 inches wider with the tire on, so almost an inch on either side, 3/4 of an inch or something like that. We have tires sticking out. So you have to consider all of that stuff. And if I could get a 7.5 inch wheel with 0 offset or even 5 or 10 millimeter positive offset, I'd be looking good. But they don't make these odd sizes anymore, 7.5, 8.5. They're all 7, 8, 10. And so I think at least under this iteration of the cure, I'm going to have to go with a 7-inch rim, which essentially is a ½ inch narrower than what I have, but they make a 7-inch rim with 0 offset. So that's just going to give me an 8-inch overall width instead of 8.5, which should help. And probably also going to have to go with a 235/60/15 instead of a 245. Now, one thing you need to consider is that not every tire manufacturer measures their tires the same way. So you can find a 235 tire that's wider than a 245 tread width, section width, or the same. So you really need to know what kind of tires you're going to put on once you decide what kind of wheels you're going to put on. And all of this gibberish is assuming I'm going to fix it with wheels and tires. The other fix is to raise the car up and just have the tire stick out a little bit, and when you go over bumps and dips, the car is raised up enough that the fender doesn't come down and hit on the tire. The problem with that is every solution creates a problem. The problem with that is I've already set my driveline angle, and if I raise the body of the car up, that's going to change the driveline angle. So that's another thing that you have to consider. You just can't get in there and put air shocks on it and crank the back end up, or put long shackles on and crank the back end up, because now all of a sudden your driveline angle's off. And quite honestly, that's what got me into this problem in the first place, because the OG guy had the pinion and the rear end pointed towards the ground. And in order to bring those of the rear end, the pinion, up in the proper angle to the tail end of the transmission, I had to put a shim under the pad that mounts the rear end to the spring. And when you do that, not only do you change the angle, but effectively you lower the car, because it's just like putting a lowering block in there. So all of this stuff is important. Before I did anything, the car sat high enough to clear the tires. And once I changed the rear end angle, that lowered the car, and now the tires rub the fenders. So I can either get smaller wheels and tires or jack the car back up and have to redo the rear end angle. I mean, it's just everything is connected. The ideal way to fix this would be to jack the car up a little bit so it clears, and then you have to cut the pads loose on the rear end housing and reorient the rear end housing and weld the pads back on. Yeah, we're not doing that, so we'll figure out another way.